Let's finish up this series here of the Annihilator approach with g of x's on the right-hand side that have sine and cosine. So we're going to come back to number 47 to start off with. Before we start, let's actually talk about what the Annihilator for this one is, and I'll actually go ahead and derive it for you. We know that we're going to get solutions that look like d equals alpha plus or minus beta I. And so that's going to turn into d minus alpha equals plus or minus beta I. And I can square both sides here and get d squared minus 2 alpha d plus alpha squared is equal to a negative beta squared. So d squared minus 2 alpha d plus alpha squared plus beta squared equals 0. This whole thing is my differential operator that's going to eliminate something that is sine, let's see, e to the alpha x cosine beta x plus sine beta x, like that, or any so let's write it this way: d squared minus 2 alpha d plus alpha squared plus beta squared to the n eliminates both x to the n minus 1 e to the alpha x cosine beta x and or x to the n minus 1 e to the alpha x sine beta x. Since both of those pieces come from the same factor, this will eliminate both of them. We're going to need to use that a little bit here. So that one's less intuitive than the other one, so I'm just going to go ahead and start with that. Now let's go back and look at number 47 here. Y double prime plus 25y equals 6 sine x. So we have m squared plus 25 equals 0 for our auxiliary equation. M squared equals negative 25, and m equals plus or minus 5i, making my complementary solution c1 cosine of 5x plus c2 sine of 5x. I have a sine x over here, so my alpha is equal to 0 because I have an e to the 0x, and my beta is equal to 1, meaning my operator here that I need, d squared minus 2 times 0 times d, so there's no middle term, plus 0 squared plus 1 squared is plus 1. And then the other piece that I have here is d squared plus 25 equals 0. So my y is going to be a cosine x plus b sine x plus c cosine of 5x plus d sine 5x, and these are already in yc, so my yp equals a cosine x plus b sine x. So yp prime is going to be negative a sine x plus b cosine x, and yp double prime is going to be negative a cosine x plus, I'm sorry, minus b sine x. So yp double prime plus 25y is equal to negative a cosine x minus b sine x plus 25 a cosine x plus 25 b sine x. That's going to give me 24a cosine x plus 24b sine x needs to be equal to 6 sine x. This up a little bit. And we have 24a needs to be equal to 0 since there's no cosines on that side, making a 0. 24b equals 6 since there's 6 sine x's on that side. B equals 1/4. So my yp is equal to 1/4 sine x, and that makes my y equal to C1 cosine of 5x plus C2 sine of 5x plus 1/4 sine x. Let's look at number 53. Y double prime minus 2y prime plus 5y is equal to e to the x sine x. M squared minus 2m plus 5 equals 0. M squared minus 2m equals a negative 5. Half of the middle number squared is a positive 1. M minus 1 squared equals a negative 4. M minus 1 equals plus or minus 2i. M equals 1 plus or minus 2i. So this is e to the 1x times C1 cosine of 2x plus C2 sine of 2x for my YC. And my alpha over here is 1, and my beta over here is also 1, making my differential operator that I'm looking for d squared minus 2 times 1 is 2 times d plus 1 squared plus 1 squared is 2. And so this is going to be d squared minus 2d plus 2 times d squared minus 2d plus 5 is going to be equal to 0. So this is going to be y equals e to the x times a sine x plus b cosine x plus e to the x times, I might as well just have e to the x up front of everything here, plus c cosine 2x plus d sine 2x. These two pieces are already accounted for in YC. So YP is going to be e to the x times a sine x plus b, sorry, this should be cosine first and sine second. like that, just for consistency, and that's because that imaginary part got absorbed into the constant there. You can look for the proof of that, but we always write the cosine part, the real part first, because this is really an imaginary part here. So then yp prime is derivative of e to the x is e to the x. And then plus, leave the e to the x alone. This is minus a sine x plus b cosine x, like so. Let's combine my like terms. It's going to be e to the x times a plus b cosine x plus b minus a sine x. So yp double prime e to the x times a plus b cosine of x plus b minus a sine of x plus e to the x times negative a minus b sine of x plus b minus a cosine of x. So this is yp double prime. A minus a is 0. B plus b is 2b cosine of x. And then negative b and b is 0. This is minus 2a sine of x. So we need yp double prime minus 2yp prime plus 5yp equals e to the x sine x. We've got e to the x's and everything, so I'm just going to look at the part that's not e to the x. I've got 2b cosine x minus 2a sine x minus 2 times, and then yp is a plus b cosine x plus b minus a sine x. And then we have plus 5 times the original, which is a cosine x plus b sine x. That all needs to be equal to e to the x sine x. With the e to the x, we've divided out, so that just needs to be equal to sine x. Put the e to the x back in our final answer when we're done. So this is cosine x times 2b minus 2b minus 2a minus 2b plus 5a, and then sine x times negative 2a minus 2b plus 2a plus 5b equals sine x. So negative 2b and 2b cancel. Negative 2a plus 5a, that's 3a cosine of x. And we have negative 2a and 2a cancel. 5 minus 2b is 3b sine x equals 0 cosine x plus 1 sine x. Three a equals 0 and a equals 0. 3b equals 1, b equals 1/3. So my yp is equal to e to the x times 1/3 sine x, which is equal to 1/3 e to the x sine x. And I have my complete y here is equal to e to the x times c1 cosine of 2x plus c2 sine 2x plus 1/3 e to the x sine x, like that. All right. Let's look at another one. Y double prime plus 25y is equal to 20 sine 5x. So m squared plus 25 equals 0. M squared equals a negative 25, and m equals plus or minus 5i, making my yc equal to cosine of 5x, c1 in front of that, plus c2 sine of 5x. My alpha here is 0, my beta here is 5, making my differential operator d squared plus 25, which is the same as this factor that's already over here. I'm going to end up with d squared plus 25 squared equals 0, which is going to make this y equals a cosine 5x plus b sine 5x plus cx cosine of 5x plus dx sine of 5x. I already have sine and cosine of 5x in my original, so I'm just dealing with a yp is cx cosine of 5x plus a dx sine of 5x, like that. My yp prime is going to be c cosine of 5x plus a negative 5cx sine of 5x, and then d sine of 5x, and then 5dx cosine of 5x. And I put those together, yp prime is equal to c plus 5dx cosine of 5x plus d minus 5cx sine of 5x. Yp double prime is equal to 5d cosine of 5x plus, then negative 5c minus 25 dx sine of 5x, negative 5c sine 5x, and then 5d minus 25cx cosine of 5x. Add those together here. This is going to be 10d minus 25cx cosine of 5x plus a negative 10c minus 25dx sine of 5x. Before I go any further, I just want to stop and check to make sure that all that looks right. Good. Okay. So I want yp double prime plus 25yp is equal to 20 sine of 5x. So this is my cosine pieces are 10d minus 25cx cosine of 5x. And my sine pieces, negative 10c, negative 25dx, sine of 5x. That's for my yp double prime, 25yp. So I'm going to add 25 times x times cosine. So that's 25x cosine of 5x. So add 25cx cosine of 5x, and add 25 times dx sine 5x, so that this piece and this piece zero out, leaving me with 10d cosine of 5x minus 10c sine of 5x needs to be equal to 20 sine of 5x. So 10d, my cosine piece, needs to be 0, making d 0. Negative 10c equals 20, so c is negative 2. That tells me that my yp is equal to negative 2x cosine of 5x plus nothing for my x sine 5x piece. So my complete solution here is c1 cosine of 5x plus c2 sine of 5x minus 2x cosine of 5x. I hope you see that we're doing the same thing as when we did our guess and check with the superposition principle. We just don't have to guess and check. We know exactly what our yp is going to be, and that's going to be really helpful in this next one here. This will be our last one for today. And I believe you'll recognize this one, that this is one that we did, or one very close to it in the last set of videos. This is the one where we probably, if you remember, we had one where we guessed wrong and had to go back and kind of start over again. But we're not going to guess wrong this time. We're going to see why we guessed wrong before. So this is m squared plus m plus 1. Squared plus m plus 1 equals 0. So m squared plus m equals a negative 1. And then this is plus a quarter and plus a quarter gives us m plus a half squared equals negative 3/4. M plus a half equals plus or minus root 3 over 2 times I. M equals -1/2 plus or minus root 3 over 2I, making my YC to e to the negative x over 2 times C1 cosine of root 3 over 2x plus C2 sine of root 3 over 2x. Now we have an alpha over here of 0 and a beta of 1, but we have an n of 2 because I have an x in front of that. So I'm going to have d squared minus 2 times alpha d plus alpha squared plus beta squared is to the nth power. So my d squared plus 1, that's going to be squared. So this is d squared plus 1 squared times, and then this was d squared plus d plus 1 equals 0. And so I know that the alpha plus beta I here, this is d equals plus or minus I, multiplicity 2. So that's where that comes from. We're going to get y equals a cosine of x plus b sine of x plus cx cosine of x plus dx sine of x plus e negative x over 2 times e cosine root 3 over 2x plus f sine root 3 over 2x. All of this is already in YC, so my YP needs to be A cosine of x plus B sine of x plus C x cosine of x plus D x sine of x. So YP, let's go ahead and write this way. So this is A plus CX cosine of x plus B plus DX sine of x. For my YP prime is going to be C cosine of x plus negative A minus CX sine of x plus D sine of x plus B plus dx cosine of x. So that makes YP prime equal to B plus C plus dx cosine of x plus D minus A minus CX sine of x. So YP double prime is equal to D cosine of x plus negative B minus C minus dx sine of x minus c sine of x, then plus d minus a minus cx cosine of x, yp double prime is 2d minus a minus cx cosine of x, plus negative b minus 2c minus dx sine of x. All right. Now I need yp double prime plus yp prime plus yp to be equal to x sine of x. So 2d minus a minus cx cosine of x plus negative b minus 2c minus dx sine of x. I'm just going to line up my cosine and my sine pieces here. Yp prime is b plus c plus dx cosine of x, and negative a plus d minus cx sine of x, and then yp was a plus cx cosine of x. This was b plus dx sine of x. So negative a and a cancel, negative cx and cx cancel, leave me with b plus c plus 2d plus dx cosine of x plus then b and negative b, dx and negative dx cancel, leaving me with negative a minus 2c plus d minus cx sine of x, and that needs to be equal to x sine of x. So there are 0 cosine x's, so b plus c plus 2d equals 0. There are no x cosine x's, so d equals 0. That just eliminates that term for me, reducing this to b plus c equals 0. I have no regular sine x's, so negative a minus 2c plus d equals 0. That d term isn't important because it's already 0. And then I have the x sine x's, so that's negative c is equal to 1. So c is equal to negative 1. If c is negative 1, this is negative a plus 2 equals 0. Negative a equals negative 2, and a is equal to 2. That being the case, b minus 1 here equals 0, and b equals 1. That gives me enough to find my yp, which was yp equals a cosine of x plus b sine of x plus c x cosine of x, and then d is 0 for the x sine of x's. So my total answer, which is my yc plus my yp, is going to be e to the negative x over 2 times c1 cosine root 3 over 2x plus c2 sine root 3 over 2x plus 2 cosine x plus sine x minus x cosine x. That will be it for this video and for this series on the Annihilator approach. Hope that was helpful to you, and we'll come back next time and talk about some examples from 4.6 in the textbook, which is variation of parameters. That's going to be the technique that we're going to use most often in the situations where the g of x on the right-hand side contains those other things that we were talking about that we couldn't use this particular method on, like tangents and secants and cotangents and cosecants and ln's and other things like that, where they weren't these things, where we could use these differential operators to eliminate them. So see you for the next video.